Hello and welcome to All Maths Considered. Today I want to look at some problem which will help us to get acquainted with some of the concepts of the graph theory. So imagine the following problem. Let's say we have a group of children, maybe a school class, and some of the children are friends with each other. We may ask ourselves the question, will we always find two children with the same number of friends? So of course we need to assume there are at least two children in the class. But given that, can we always find two which will have the same number of friends? Let us think about this. If we take one child, how many friends can he have? Let's say we have 20 kids. How many friends can he have? He can have 0 if he has no friends, or maybe 1 friend, 2 friends, and so on up to 19 friends. So this gives 20 possibilities, 0 to 19. Now, we have 20 kids and 20 possibilities. And let's assume any two of the kids have different number of friends. Then we must have one possibility occurring exactly once. So we must have one kid with 0 friends, one kid with 1 friend, and so on, up to one kid with 19 friends, which is impossible because we can't have a kid with 0 friend and at the same time, in the same group, have a kid with 19 friends because the first one will have no friends and the second one will have all other kids as friends. That will lead us to a contradiction. So we cannot have that. So we see like this that we must have always two kids with the same number of friends. Now that we understand how this works in this setting, let us now look at the abstract concepts of the graph theory and formulate the same argument, just the same, but in a formal way, so that we can get used to the language of the graph theory. So let us consider the following model. We denote the children in our class by little dots. And each time two children are friends, we'll connect them by little intervals, like this. So we may have a picture like that, which we call a graph. The little dots will be called vertices of this graph, and the intervals will be called edges of the graph. Now, given any vertex, we can look at the edges containing this vertex, and we call the number of these edges valency of this vertex. Now, what we said before, we can formally state as a theorem. The theorem says that any graph with more than one vertex has vertices of the same valency. What we said before as an argument can now be formulated as a formal proof. So we don't know how many children we have or how many vertices. So let us say that our graph has n vertices. So let us say that our graph has n vertices, n is some number, and this number is at least 2. Now, just as we said before, possible valencies of vertices are 0, 1, 2, and so on up to n minus 1. And now, just as before, we can notice that having valencies 0 and n minus 1 is incompatible. So these valencies are incompatible in the graph because a vertex with valency 0 is connected to nobody, and the vertex with valency n minus 1 is connected with everyone. That cannot happen at the same time. So we are done with the proof. This sign denotes the end of the proof.